Hi, everybody. So this is our last cycle. Got a few things to do. Just a reminder of where we've come in this class. We started off talking about atoms and electrons. We then looked at how those electrons can be located via photoelectron spectroscopy. And then we started transferring those electrons to form ionic bonds and sharing those electrons to form covalent bonds. We saw that those covalent bonds made shapes, and those shapes made things polar or nonpolar. Based on that polarity, we had states of matter, solids, liquids, and gases. And now what we're doing is smashing them together to create new bonds in chemical reactions, right? We took a little detour in that to talk about the gas phase specifically with PV equals nRT. So now we're going to do what we've been doing in the past. We're going to go to our little area here, and we are going to rid ourselves, unfortunately, of some areas that make me so sad because I work so hard to plan this curriculum, but I'm not a victim, neither are you. We're going to do our best because we love each other, we love chemistry, we love science, we keep it real. Oh, look at that s'mores. Let's not even talk about that. Okay, so we're going to get here to this practice region, and what I'm going to challenge you guys to do is do all these practice problems in today's class. Um, Between now and actually, let's see here. I'm going to challenge you to do these first ones in today's class. So starting here and ending here. All right, so I'm going to do a few. I want you to do them first, and then I'll pause the video and then play again to see if you got it correctly. So again, what we're trying to do is get the atoms on the left side of the reaction the same as the atoms on the right, because we know that in science, you don't ever lose matter. So the reaction must happen in some proportion. So let's take a look at this. And here's the way I like to do it. I draw a little line here, and I look at the sodiums on the left. I see that there's one, and I look at the sodiums on the right, and I see that there's one. Perfect. I look at the chlorines on the left, I see there's two, and I look at the chlorines on the right, and I see that there's only one. So I need to put a 2 here. Okay. Now I'm going to go back every time I add a number. I'm going to go back and count again. So now let's start over. Now don't forget, the moment you put a number there, that then becomes distributed throughout. So that 2 counts for that Na and that Cl. So that means you have 2 NAs and 2 CLs. I'm going to erase this so that it doesn't make my instruction look janky. Okay, here we go. Okay, so now I'm going to start over. How many NAs here? 1. How many NAs here? 2. Okay, so now I got to put a 2 there. Now I got to start over. How many NAs here? 2. How many NAs here? 2. How many CLs here? 1. How many CLs here? 2. How many CLs here? 2. And a lot of people get stuck right there because they forget to count that 2. Okay, so that means that now we're balanced. 2 NAs, 2 NAs, 2 CLs, 2 CLs. Okay, so oftentimes I'll put a 1 there just to seal the deal. Let's go through and do a different one. I'll do this one here. Okay, so put a line here. How many NAs here? 1. How many NAs here? 3. So what do I got to do with that 3? I got to put a 3 here. Okay, so now I put a coefficient in the front. Let's balance it again. How many NAs here? 3. How many NAs here? 3. How many H's here? 3. How many H's here? 2. So whenever you see 3 and 2, just swap them with each other, because what you're really doing is making a least common multiple of 6. So it's kind of like adding 1/3 plus 1/2, right? You would cross multiply to get 2, 6 plus 3, 6. Okay, so take a look here. How many H's here? 3. How many H's here? 2. So I'm going to put a 2 here to make this 6, and I'm going to put a 3 here to make that 6. That cross I'm talking about. Now I'm going to go look at it again. How many NAs here? 3. How many NAs here? 3. How many H's here? 6. How many H's here? 6. Because you multiply that coefficient by the subscript. How many P's here? 2. Remember, a lot of people are going to say 1, 2, because you multiply that through. How many P's here? 1. So you got to put a 2 here. Oh, so now the NA's changed. Let's go back and count it again to make sure. How many NA's here? 3. How many NA's here? 6. So we got to change this to a 6. So now let's go back and look at it. How many NA's here? 6. How many NA's here? 6. How many H's here? 6. How many H's here? 6. How many P's here? 2. How many P's here? 2. We're balanced there. Okay. And then one last one is this one I'm going to do with you. And I'm doing this with you to point something out. When you're doing a problem that has a polyatomic ion, now remember, this is the polyatomic ion nitrate. When you see polyatomic ions, the first thing you want to do is see if they show up on both sides. So you see how you got an NO3 here? We got an NO3 here. So let's balance the NO3. Let's put a parenthesis around it. Okay. So I got no other polyatomic ions, and they're going to show up in other spots too. You know, they're showing up here and here. But the reason I'm showing you this is when you balance this, do not think of the N's and the O's separately. I want you to treat the NO3 as one thing. So we're going to balance the NO3s because they always travel together. So let me show you this. Okay, let's start. How many PBs here? 1. How many PBs here? 1. How many NO3s, because we're treating it as one thing? 2. How many NO3s here? 1. So we got to put a 2 in the front. So now let's start over. How many PBs here? 1. How many PBs here? 1. How many NO3s here? 2. How many NO3s here? 2. How many Ks here? 1. How many Ks here? 2. So I got to put 2 here. So now let's start over. How many PBs here? 1. How many PBs here? 1. How many NO3s here? 2. How many NO3s here? 2. How many Ks here? 2. How many Ks here? 2. How many I's here? 2. How many I's here? 2. Okay. So what I'd like you to do for today's checkout is to finish the rest of these and see if you can do it. And we'll review those during class next time at the checkout. So don't move on to these, please. Yeah, we'll work on those later. All right, take care.